Okay, so this talk is mostly about Pigeon, which is a really small educational language that I've created just a couple months ago. I finished it. I hope none of you are here to hear about Pigeon, P-I-D-G-I-N, because that's the IM client that was formerly known as Game. I came up with a name first, but they were the bigger project, so I should change my name, get out of the way. For now, I'm just calling it Pigeon, P-I-G-E-O-N, just like the bird. If you have a suggestion, I'd like to hear it. So. The reason I called it Pigeon is because what it means is it's a language that's based on a simplified grammar and lexicon taken from one or more developed languages. So it seems really appropriate as an educational language. I thought it was a really cool name for an educational language and only an okay name for an IM client, but they get their way. So I was going to call it Pigeon with a Y, but that's a bad idea. Y as an homage to Python because it's in many ways based on Python. But it's an unguessable spelling if you spell it with a Y. No one's going to ever guess that if they try and type it in Google. So sorry for the confusion. Pigeon's actually only a smaller part of what I want to talk about. The larger topic is about programming education in general, why it's important and so forth, and what can be done about it. There isn't too much to say about Pigeon itself because that's largely the point. It's meant to be a really simple language where there's just not much to say about it. Okay, so the obvious solution to educational problems is to simply teach better, but another approach is to actually simplify the subject matter itself, and so hence educational languages like Pigeon. Of course, there are already a number of educational languages that already existed, but for one reason or another, I found there were something unsatisfactory about them. I explain it in this blog post I wrote. Also, many people prescribe Python as the best first place to start, and that's certainly true, I think, it's my favorite language. It's certainly true it's the best choice among the real languages that are available. But it's still a real language, and real languages tend to have just dark corners that are complex and annoying to deal with, even in an exceptionally well-designed language like Python. So the idea is to create an artificially simplified environment where students get grasp of the essential ideas in programming. So there's the URL for the page on Google Code. It's TPL3. It's currently only about 1,000 lines of code for the implementation because it's written in Python and it's done in the crudest possible way you could write a language is have it spit out into some other high-level language, and that's what I'm doing. It actually just takes each file gets converted into its own module and run like that as Python. But the student doesn't have to see Python. They don't realize they're using Python, though they do have to install it first, of course. So the embarrassing part is that it's currently kind of broken, actually totally broken. You can't use it. I've been putting it off to prepare this, fixing it. It'll only take me a few hours once I get to it, but I've been putting it off to prepare this presentation and also to write the documentation. But now that this is past me, I'll do it this week. It'll only take a few hours. Even more embarrassing is that I actually wrote it on Windows, and in fact I didn't bother to do the path handling platform agnostic, so I have to fix that too. It'll only take an hour, but I just keep putting it off. I'll be sure to have it working sometime this week. Okay, so the main thinking behind the language is first get in, get out. The idea is that learners should spend only a very brief time with an educational language like this. It's just meant as an introduction. It shouldn't take more than 6 hours at tops to learn the entire thing. And once they learn understand the language and all its rules, they can spend a few days, maybe a week, trying simple programs. It should only take a few lessons. If this were done formally in a classroom, it should only take a week or two, maybe, depending upon how much class time you have. It should be fully grokkable, too. Most real languages, even experts don't really understand all the corners. Obviously, that's the case with like C++, but even simple languages like Python, there's a few things. Not everyone who uses it professionally really understands everything about it. So I think it's very psychologically important that students be able to say definitively they know everything there absolutely is to know about the language. I'm sorry.
But just curious, so what target audience are you looking at? High school?
No, most educational languages do focus on younger students. I say, sure, you could show it to kids, but it's not meant to be cartoony in any way like most educational languages are. There's no cute graphics. It doesn't focus on doing graphics. So in that sense, no, it's not for kids.
High school or college?
Certainly high school. Anyone, I would say a smart 10-year-old and up. Maybe even someone younger. I don't know. I think only testing would show, really. But it's not explicitly designed for kids. It's designed for anyone who wants to learn programming. It's just meant to be a really efficient start. Like, learn this in 6 hours and be done with it in a day. Okay, so it's meant to be fully grokkable, and the way you have to do that is you have to make it simple enough in the first place that there's not any dark corners. So that's the main concern. And the way you achieve that is that as you design it, as you're designing, how do you actually explain this? So you can't just add features without concern like C++. You have to think, well, how is someone totally new going to come to this, and how are they going to see it? That's really important. So it's dynamic, of course. There are some educational languages that choose to go to the static route. I think dynamic is it's just simpler. You don't have to, less syntax for one. Like in Python, the way you assign is you just have an assignment, and it's implicitly there as a local variable in the function. It's indentation sensitive, just like Python. It uses prefix notation for everything. So I think most languages stick with infix notation, where you have 3 plus sign 5. The problem is that, okay, it's familiar, but what about operators that they don't know from math already? So, like or, logical or logical and. They have to learn the order. They have to learn the order of precedence, and they have to learn associativity and other rules like that and subtleties. So I think familiarity isn't really a big deal. And prefix notation makes everything uniform, so all the function calls look just the same as regular operator calls. I guess you don't call them calls, but... Okay, and all the operators are keywords, so you don't learn any funny symbols. Everything's just 3 short letters mostly, so it's add instead of plus, stuff like that. And there's no explicit object-oriented programming facility in the language, but it does have dictionaries, and so you can do it by convention. What you do is you write a function that produces, as your constructor, it's just a regular function, but it spits out some object, and you give that object all of the same methods as properties, and so therefore it can act as an object that you can call. Obviously, real languages aren't implemented that way because you don't want to have all your instances of some class each have their own particular pointers. That's not how they work internally. It's wasteful. But, it's meant to be efficiency, and, performance is not a concern here. It's also much simpler to understand object-oriented built up from just basic convention this way. It's much less mysterious. Okay, here's an outdated screenshot, also in Windows. So to give you an idea, at the top, I've changed a few things about the language, but it comes as a GUI. You don't have to deal with your own text editor. It also gets rid of the issue of indentation, spaces versus tabs, so you're never going to run into that trouble because it knows exactly how many spaces a tab equals. So a function definition simply has the syntax of you write function, and then the name, and then after that, you just list the parameters. There's no parentheses or anything. I find that learners get confused by any kind of superfluous syntax, even if the syntax makes things clearer, like commas separating parameters or arguments. You don't need those with prefix notation, so you shouldn't have them. You shouldn't have anything that isn't absolutely necessary. And so you just indent in under the function, just like Python, just like that word def, and you list all the statements. This is also out of date because it shows there a main block, as in print. I'm sorry, just like in a Python module, you have some number of statements that get executed outside of functions, but I changed that, and so now everything is just functions, and you have a main as your start. So modules don't start by, they start by executing main. This is, at the bottom, is where all the print output appears. So every time you call print, it appears here. It's important to dodge the issue of operating system concepts. Even something really simple like standard out and standard in. It's simple when you do simple things with it, but it's really hard for students to understand because it comes with all these other conceptual issues. And so it's nice just to totally dodge that. And so the way input is done is if you call the input operator or function, it'll just give you a pop-up. So that's how you can write a program that has input and output. It'll give you a pop-up where you enter text.
Why is the parentheses? You don't use them?
Oh, I'm sorry. No, it's prefix notation.
Yes, but why do you have the parentheses in the parentheses?
Oh, yes. Because every expression, everything that is an expression, I say explicitly should have the parentheses. For consistency, originally I was thinking you'd be able to leave them out on the outermost expression, but I found it was more consistent just to always have that. So a student can look and see, and they can see everywhere that there is an expression because they'll just look for the parentheses. So they'll always look the same. Okay. So in the future, where I might go with this is first I might just add Turtle and Canvas graphics. Currently, it's just my thinking is they'll just do simple console applications, really simple stuff like guess the number games, traditional stuff like that. But it'd be more fun to do some Turtle graphics or Canvas graphics. You know, Turtle graphics like from Logo. You have the little cursor that moves around and you tell it where to go. That would be pretty simple because Python already has a Turtle module. That's pretty nice. So it would just take a few hours to write up a hook into that. Also, I might write a static or functional variant. So the idea is you'd learn the dynamic version first, and then to get a contrast between dynamic languages and static languages, you can then use the static version of Pigeon. And then maybe you might also have a functional variant so people can get the idea of what does it mean to have a functional language. There's a lot of confusion about that. I'm not sure about that. Also, an interactive mode, currently there's no interactive mode. A lot of people find it helpful or say it's helpful in Python. It's neat because you can just have your console and you can type an expression and experiment that way. I don't think it's such a big ideal because it's a big problem because the lack of one is not a big problem, I think, because you're writing really small programs anyway. It's easy enough to just change the code and hit F9 to run your program again. Also, with prefix notation, the expressions are simple in the first place, so it's not a big deal, I don't think. I'm not sure. I'll have to it'll wait to test and see if people really complain about it being lacking. Okay, so education in general. First, why should you care? Why should the free open source software community care about learning? Second, why is teaching and learning of programming hard? And finally, if Johnny can't read, what do we actually do about it? So first, why? Who cares? What benefits would we see if learning were somehow easier? Well, first, consider the effect of learning difficulties on the end-user side of things. Learning barriers mean fewer users. I could justify this point, but I think it's pretty self-evident, so I'm not going to. What I do have to say about this, though, is that there's a problem in this community. We tend to often talk about users as if we exclude the middle. We tend to think, well, there's expert users, and then there's your grandparents, right? And there's nothing in between. But, of course, there actually really are many people in between. Most people are computer users a step or two above your grandparents, and there are a large number of users out there who have quite a bit of Windows or Mac expertise, but for whom Linux is still scary. Like I say, half of the adoption problem among these users lies with the familiar lingering deficiencies in Linux itself. You know, the software just isn't there yet in a few critical areas. But the other half of the problem is the learning pain of dealing with a complex and familiar system. So, for instance, a window gamer is deterred from installing Linux not just because of the difficulty and uncertainty in getting World of Warcraft to run under Wine. He's also equally deterred by the inevitable pain involved in learning the first thing about how to get World of Warcraft to run under Wine. So, in fact, most such users likely don't know what Wine is, right? And that just compounds the scariness of Linux, because Linux is full of complex things you haven't never heard of but may have to deal with if you're going to use it. For non-expert users, the situation is actually a bit better for non-experts, because projects like GNOME and Ubuntu have consciously advanced the Linux desktop for the sake of these non-expert users. And we're now at the point where Linux can meet the needs of most non-expert users out there, as long as those users have a sufficiently expert user around to configure and maintain their systems right, which is what I do say with my parents. Oops. Dope. In fact, that's how most non-expert users deal with their Windows machines. They have someone else come and fix it when something goes wrong, which happens a lot. So it's my suspicion then that one of the biggest factors currently holding back Linux adoption among these everyday users is a lack of expert users to support them. So And while there's plenty of consciousness in the Linux community about fixing Linux's deficiencies and accommodating layman Windows and Mac users, there's virtually no consciousness in the community about accommodating expert Windows and Mac users. So what's needed is some kind of conscious effort for that. Learning difficulties, of course, also hold down the number of developers working on free software. So first, all sorts of learning obstacles hinder developers with the inclination to work on free software from actually doing so. It also holds back people who are currently already working on projects, but it prevents them from picking up new projects. You know, they're limited to one or two maybe, or not just because of time, but the effort involved in, you know, reading some of the code base. So these obstacles are things like language and tool fracturing. You know, the complexity of languages and their associated tools wouldn't be such an issue if we could all just settle on one or two choices. But of course, the reality is there are dozens of languages out there, and most programmers only know a few of them, and often only one of them well. What's worse, learning the tools surrounding a language can be just as daunting as a new language, and a significant majority of commercial developers out there live in the, you know, the Microsoft Visual Studio world or the Java IDE world, and so they're used to these elaborate all-in-one dev environments. Such developers typically find it daunting to wade into the more piecemeal Linux dev process. You know, a lot of people would sneer that they don't want those kind of developers anyway. I think that's a misguided attitude, but that's a whole other argument. Domain knowledge. So to work on a project, you can't just speak the programming language. You need a decent familiarity with the domain. And some domains of programming are more black magic than others. So for instance, it's my impression that, say, x.org and all things graphics and open source have been wanting for manpower in recent years, even though these are really critical and actually relatively glamorous domains to be working in. There's just a shortage of people working on it, even though the people we have are really good. Meanwhile, it seems everyone and their dog has written an XML parser. So this discrepancy is likely because, you know, while XML tools deal with nothing more arcane than text files and the mysteries of Unicode, you know, a programmer can't get anywhere in graphics without knowing a whole lot of stuff that's not taught at, like, the typical university program. Community processes, simply, heavy development processes suck, not just because they're hard to work, but simply because they're hard to grok in the first place. Code-based complexity, it's of course an intractable problem, but if every line of code were into impeccable standards, it would still take a large investment of time and effort to read a large code base. For reasons I'll discuss later. Unfamiliar code is almost always just hard to read. Not only does this hinder potential contributors, it encourages... Excuse me a moment here. I've lost my cursor. It encourages them to duplicate your effort by starting their own project. So, particularly among smaller projects, this happens. Coders would generally rather write their own code than have to find, read, and understand existing code. It's not as irrational as it sounds, because the pain of searching and learning may just go to waste in the end. You can't know before you look whether you're going to find what you want, but if you write your own, at least you'll be certain that you're in control, and in the end, you're going to understand the whole code base. So it's appealing to just write your own, at least with small projects. Keep hitting that button. As an aside, you know, as someone who's browsed many project sources, if there's one thing I think projects really need to do as a small favor is there's one kind of documentation you need to provide. You should include a manifest giving a brief list of all the files and, you know, where things are and justify why that file exists. You know, that's a very easy kind of documentation to produce, and also it gives anyone coming to the code base fresh, you know, a real leg up. Even if you're following like standard conventions, like, you know, a PO file for a directory for internationalization, you should still explain that, because, you know, not everyone understands those conventions. It would help a lot. Okay, so another consequence of learning difficulties is that many libraries just go underused, or at least they're slow to see adoption. So there's not much to say here except a brief rant. If your project is mainly used as an API, what excuse do you have not to document it? I mean, what's the point of a library if people can't understand how to use it? So if I, the API user, have to learn everything you, the developer, did when creating it, that's defeating like 80% of the whole purpose of using a pre-built library in the first place. I don't just want you to do stuff for me. I don't want to understand what you did. So poor library documentation is doubly disastrous, because if your code is hard to see, you're not just keeping out potential users, you're keeping out potential contributors as well, because your potential contributors are going to be your users first. When learning is painful, learning to do the right thing is painful. So consequently, most people take the path of immediate less resistance, no matter how suboptimal the process is. So for instance, a crane with a really thick manual means just using a shovel. For instance, I may have heard that Emacs or Vim are more powerful ways of text editing, but no one is around to get me started on the basics, and their manuals are 400 pages long. And why want the crap with this stupid program and just simply type Control-C, Control-C, Q, 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 escape, 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 and it doesn't work. It's really frustrating. Or perhaps I'm someone who's aware of version control, that it exists, but I have avoided trying it out because the Subversion manual is 370 pages long. Or maybe I'm a Subversion user that has heard great things about Git, but its manual is 400 pages long and incomplete. And how the crap does version control work without a central repository anyway? Distributed version control seems like contradictory in terms. And Linus is going to call me stupid if I don't get it all right away, so I'm not even going to try. So you can end up wasting a lot of time because of this initial pain, these initial barriers. Also, when learning is painful and learning to do the right thing is painful, people will often go to ridiculous, self-defeating lengths to avoid that pain. So what results are a lot of what the fucks. You can see this with the ignorance of newbie programmers. They end up creating crazy solutions to already solved problems. And they write stuff like this. But also say a newbie may write thousands and thousands of lines of code. They don't need to because they are simply unaware of the existence of regular expressions. Or maybe they're really new and they don't even know what relational databases are for. So they end up doing really stupid things. A lot of what the fucks are caused not just by ignorance, but by flawed conceptual understandings. Like when I was 10 and I had my first computer, it was a Packard Bell 386 with 2 megs of RAM running DOS. And I installed an adventure game, but it refused to run. And the error they reported was insufficient memory. So of course what I did was I proceeded to delete as much stuff off my hard drive as I could. And I freed up 20 megs on my 40 meg hard drive. And strangely enough, it actually worked. So, and I still don't understand why that worked, because of course I wasn't addressing the fundamental issue. I fundamentally misunderstood the problem. I just got lucky. But of course, most what the fuck perpetrators, they're not so lucky, and they cause enormous problems for themselves and the people who come after to clean up after them. Finally, it seems some segments of our economy are like infested with incompetence. Computer repair, for instance, is notoriously filled with amateurs who have little idea what they're doing and who largely operate on superstition. Better education can't really combat this problem because in many cases it's just fraudsters, and they don't want to learn stuff. But education can at least improve the ratio of the competent to the incompetent and thereby perhaps spread sufficient knowledge that more people can detect incompetence at least. So, all these problems I've discussed would be solved or mitigated if learning were made easier. But learning is not easier, so how do people actually manage to learn programming today? Okay, first, there's little consensus. If you ask 10 developers how they learned programming, you would probably hear 10 different stories. In contrast, in physics and math and other fields like that, there tends to be a shared, similar educational path through the subject matter, at least in the lower level stuff. And doctors, though they specialize, there's a successful consensus in medicine of what core training constitutes a doctor. Little of the kind exists in programming. In particular, few people can agree upon the best entry point into programming. What language should I learn? Should I start with HTML and JavaScript, or should I start with an assembly? Should I use an IDE, or be forced to start with a command line and Emacs? It seems every programmer on the web has an opinion about this, and they're all different opinions. Most programmers most likely get the bulk of their initial programming education through formal instruction. The state of programming instruction can be summarized as inconsistent, which is really just a polite way of saying that a lot of teachers suck. Really, though, there are plenty of good teachers out there. However, for every good teacher, it seems like there's a bad one. Bad teachers are not mere annoyances. They are dangerous. The net effect of a bad teacher could be not just passive hindrance to a student's education, but actually actively damaging the student's grasp of the subject matter because of bad information and poor misleading explanations, which are toxic, which are themes I'll come to later. Now, of course, I keep losing my cursor. It's hard to see. This is impossible. Okay, well, of course, the same can be said about bad books and bad web resources. They're also really damaging. But teachers are generally worse because books don't grade you and they don't make you do homework. So their influence is, you can at least turn the book down, but typically you have to take courses for credit. Okay, and so also aside from teaching, there's books, books, more books. This is at Fry's in Oxnard. They have four full aisles of books, programming books. Almost all of them are programming books, and all the shelves are filled. So, and they also have some racks too, so that's not even the extent of it. Most people who succeed in learning to program didn't primarily teach themselves from books. It's more common that someone picks up books later to learn new stuff. But I did learn from books, and I'm probably a very unusual case. The reason people don't learn from books, I think, is apparent from this picture. From the total newbie wishing to go the independent learning route, the array of choices of simply where to start can be by itself overwhelming. So before you've even learned anything, you're already confused. The third basic way of learning to program is to simply learn by doing, and this is in fact how most people really learn to program. Well, hands-on learning is of course an essential part of any education. I can't endorse learning just by doing because, first, I think that approach is tantamount. Educators saying just do it is tantamount to giving up. It's just throwing your hands in the air and shrugging. You figure it out. More importantly, learning through proper instruction and teaching materials is, if done correctly, far quicker and more efficient than a student struggling on their own with a compiler. So, again, I can't find my cursor. It's totally disappeared. Probably a bug. Hold on a second.
You see it on the screen.
Oh, that explains it. It's one on to the other. Okay. Duh, I didn't think of that. Okay, so whichever of these three ways of learning, formal education, books, or just coding, the problem with all these approaches with the prevailing level of quality of education is that you end up with a very patchy understanding of all things programming, so from languages to basic computer internals considerations and so on. These flaws and gaps in your education, they take years and years to correct and fill in, and those years are usually spent on the job creating what the fucks. And some practicing programmers never really get past this patchy phase. Okay, so there's some special learning challenges that are unique to programming, or at least uniquely acute in programming, and here are a few. First, like law and medicine, programming is virtually endless. You may have seen this on Reddit recently. It's a tree map of the whole .NET framework by type. I forget what the number of classes was. It was really big. You can see at that link down there. He calculated everything. Of course, no programmer ever learns near the entirety of these libraries, and you might argue that the huge libraries of C# and Java are reasons even expert programmers should simply avoid using those languages in the first place. But the sheer mass of the stuff available to learn is still daunting. Even if the student gets advice about which stuff is really worth learning, the advice from different sources is often totally contradictory, and the student is still stuck in a position of being able to judge for themselves about what they should really put effort into learning. Concepts in programming are generally abstract. And the good news is that most of the really important ideas in programming are actually very simple, like, say, the basic data structures that we use in over 95% of all situations. They're not rocket science. The bad news is that abstractness makes these important, simple concepts difficult to verbalize, so it can be very hard to teach these otherwise simple things. Anyone want to guess what these acronyms are all referred to? It's a category of thing. You probably won't guess. Anyone recognize any?
Well, there's printer control language. There's Kernighan and Ritchie.
Yeah. I don't think that stands. No, that stands for something else. It's meant to. These are all books. So this is how fixated programmers are with acronyms and initialisms that we have. Even our explanatory texts of the field, we give them cryptic names. And of course, we don't just stop with books. It wouldn't be so bad, but a lot of abbreviations, acronyms, initialisms, they're anachronistic. Like TTY is short for teletype, but no one uses teletype machines anymore. But it's still called TTY for historical reasons. This is important because it's generally much easier to remember acronyms when you can remember what they stand for. So, for example, the C library function sprintf, it'd be much more easier for students to remember if they were told what it's an abbreviation for, string print formatted, I assume. I'm kind of guessing. I don't think I've ever seen a formal explanation of what it really stands for. I'm sure anyone knows. But anyway, if you provide that extra context and emphasize what it stands for, the cryptic names they're much easier to remember. Otherwise, they're just a random piece of information. And it's really sad because, particularly in that case, every C book I've ever looked at, they don't explain what printf means. It means print formatted or print format or something like that. It would just be much easier to remember. Aside from cryptic acronyms and abbreviations, terminology is by itself a problem, and it is as it is in any field. But what's unique in programming is that we compound this problem by naming overload, because each program we write itself defines many internal names unique to just that program. And so the student, anyone coming new to programming, is overwhelmed just by all these names. Not only are programs comprised of thousands of contrived names, those names are related to each other in a complex web. So even the best organized and engineered code can be frustrating to read because the code that corresponds to what seems, from the user perspective, like one piece of functionality, is typically scattered among various places in the code base. So it often feels reading code like a wild goose chase. Just when you think you found the bit of code that does the real work, you're told, no, it's actually somewhere else. Please check there. I think I've hit 5 more minutes, I guess. It's 40 after, and I started 10. Pushing back 10, okay.
Nobody's showed up for the next talk.
No, her talk here? Okay, so I'll go 5 more minutes. Notation. You probably can't read this. Maybe some of you can, but the fact that you can't read this makes it seem much more complex than it actually is. And the problem is that learners, they're stuck at this surface level, and they see syntax. And so a mistake a lot of educational materials make, a lot of teachers, is they kind of underestimate how you can't just throw the syntax at the student and expect them to remember instantly. I mean, you have to really keep reminding them, walk through, like, say, an example of code on the second day of a class and keep reminding them what each thing does. A big problem is overloading. That makes notation really hard to follow, really confusing. Like, say, the dot operator in Java, it actually means several different things in different contexts. I mean, it has this vague general definition of x.y means y is something in x, but in different contexts it means quite different things. And historical cruft. Programming is in many ways easier today than it was in the past. So I no longer have to write hello world in assembly for it to run acceptably. But newbies, they're like readers trying to pick up a complex Russian novel by starting in the middle. You're coming in the middle of something really complex, and by now a lot of the existing complexity is necessary, but a lot of the stuff that's complex in software is just historical cruft. I'm not sure what there's to do about it, but that's why programming is hard. Okay, and were this talk like an hour longer, I could go on and on about the various ways in which programming books and programming instruction go wrong. Instead, I'm just going to hurry through. Okay, well, I have some slides. This one's really big, misinform, mislead. There's tons and tons of misinformation out there and tons of bad explanations. And the problem with bad explanations in particular is because you, the author, understand what you wrote, it's hard for you to detect that someone would misunderstand it. That's a really big topic. Another big problem is a lot of teaching is incomplete. This is the K&R book for the C programming language. I think there's one particular reason it's so well regarded. Most of the text is not that wonderful compared to other C books, but it does a couple things that no other book does. It's more complete. It gives a proper accounting of the relationship between pointers and arrays, for instance, and it also teaches function pointers, which no other C book I've ever seen has done. I mean, I've looked at every C book in the last 20 years, and none of them teach function pointers. So you either have to just pick it up, you either have to read code and encounter the function notation, which is totally cryptic. I mean, the function pointer syntax in C is crazy, but anyway. So it's important that things are complete, because what really sucks about incomplete books is, say I've read my first book on Java, but it's incomplete, so then I have to go out and read 2 others to pick up the really important stuff, and that's really frustrating because you're reading stuff, most of which the stuff you want is buried in like a few select pages out of this 700-page book. Also, it's important psychologically because it really helps the student's confidence if they can, say, have some book on a topic, a language or a library. If they can hold in their hand everything that there is to know about a topic, you don't have to look elsewhere. So you may not understand it yet, you may not know all of it, but at least it's there in your hand. You don't have to. It's not somewhere else. Presentation order is really, really, really important. If you're trying to teach calculus before arithmetic, you're just not going to get anywhere. And the trouble for authors and teachers is that most complex topics seem to have recursive dependencies. The student can't understand A before they understand B, but B really can't be understood without A. So the answer, though, is that most of these recursive dependencies are really only illusory. And it simply takes a lot of hard thinking and many, many revisions of your presentation order before you sort them out and find an untangled presentation order. But unfortunately, most teachers just give up their search too quickly, and most books as well. There are three modes of exposition. There's reference, tutorial, and narrative. A reference is just an information dump, hopefully organized in some kind of easy-to-search and browse fashion. And a tutorial is not explanatory, it's hand-holding. It's walking through all the detailed steps of a process. Finally, narrative is explanation and elucidation. It's the presentation of concepts and arguments. And a major problem is that most books tend to mix these modes together at random intervals, so they'll switch back and forth, particularly between narrative and tutorial. The reason this is suboptimal is because good narrative should be good storytelling. And when tutorials interrupt the storytelling, it's just as annoying as like when watching a movie and getting interrupted. In fact, I really, really hate tutorials because of this. So I have an irrational hatred of tutorials. And what I hate most is that a large majority of the web resources out there, they're written in the tutorial mode, and not out of careful consideration, but simply out of laziness, because narrative is very hard to write at all, let alone write well, whereas tutorials almost write themselves. You just pick a topic and a starting point, and you proceed from there, and it pretty much falls out. It's not that tutorials don't have a place, it's just that they're actually quite important, but they should function primarily as supplements to narratives, and they should be independent from the narrative. You shouldn't tie narrative to tutorials. Okay, and so finally, that's actually kind of it. If I had 15 more minutes, well, just briefly, I'd like to take this beyond. Pigeon is actually just a small part of what I would like to plan. I would like to just have it be the beginning point for a much larger set of teaching materials that I've already spent a lot of time developing. You can go to learnprogramming.tv. It's a mess right now. It's a wiki. So I don't really recommend you look at it, but you get a sense of what I want to do is build a much bigger project that builds the bridge from Pigeon, basic programming concepts that are left out of most language books, like really explaining how numbers are represented as bits, how information is represented in bits, information theory. Learners really need just the basics. They're actually not that as complex as people often think. And they really help learners. And I'm rambling because I'm out of time. Okay, but the basic idea is that it would be some project that's like a cross between Wikibooks and the Linux documentation project or other similar efforts to produce free open source learning materials. The problem with Wikibooks, if you've looked at it, it's an extension of Wikipedia. But the reason it doesn't really work or it's problematic is because Wikipedia works because it's a wiki with a whole bunch of discrete information. And discrete information is easy to build in a wiki because the parts aren't interdependent. But a book is, as I was saying, progression is important. It has a lot of interdependencies, and they're really critical to get right. And so what you need is some kind of process that, a functioning community process that somehow maintains a consistent narrative. I don't have a name for this project, but you can read about it on my blog. I'm sure I'll post more about it. And that's it.